So we talked about polynomials. Now we can talk about rational functions. So here in example 3, let's look at something that's a rational function. And notice we didn't talk about horizontal asymptotes in the polynomial part because you don't have any. But with rational, you have the opportunity to have some of those. So here is A. We're going to take the limit as you approach both positive and negative infinity. So here is my function. 3x plus 2 over x squared minus 1. So that's what we're looking at. Now, back in algebra, when you were looking through this, you just learned specific things, right? Oh, how do I identify a horizontal asymptote? And you look at this and you say, oh, my degree in the denominator is bigger than the numerator. I automatically know my horizontal asymptote is y equals 0. Yes, we automatically know that. And then we go even farther now because we know limits. So back in the algebra stage, you looked at that and you knew what was going on because that's what you were told. Now that we know calculus, we can prove why that was the case. All right? Okay. So I have f of x. Let's take my limit first. The limit as x approaches infinity here of 3x squared plus 2 over x squared minus 1. When you approach infinity, all right, as you are approaching infinity, you can look at this and then say, oh, okay, I'm approaching oh, you're hollering at me. Thank you. As you approach infinity, you say, what is my highest exponent? In order to simplify this rational expression into something that we can work with, you are going to multiply by the highest exponent, basically. My highest exponent is x squared. So I'm going to multiply the top by 1 over x squared and the bottom. As long as you multiply the top and the bottom by the exact same thing, you're not changing it. All right, so look at what happens here. I've got this that I'm going to write all of this out first, just so you can see it. 3x over x squared plus 2 over x squared over x squared over x squared minus 1 over x squared. Then you simplify. I'm taking my limit as x approaches infinity of 3 over x plus 2 over x squared, 1 minus 1 over x squared. Now, what did we say already? As x goes to infinity, positive or negative infinity, remember we said either one. If you approach positive or negative infinity, it doesn't matter. If you have a number on top and a variable on the bottom, that whole thing goes to 0. So what I actually have here is 0 plus 0 over 1 minus 0. If 0's on the top, that is legit, and I'm at 0. Which tells me my horizontal asymptote is y equals 0. And because we know it doesn't matter if I'm going positive or negative infinity, right? So if I take this exact same thing, the limit as x approaches negative infinity of 3 over x plus 2 over x squared, 1 minus 1 over x squared. It doesn't matter if I'm doing that, positive or negative infinity, we learned that still goes to 0. And my limit is 0. So my horizontal asymptote is y equals 0 no matter what for this particular one. You see that? Highest exponent, your highest exponent. We're going to do a couple of them, writing them all the way out like this, just so you can get the concept down. But moving forward, I expect you just to be able to do that in your head. Let's do another one. Here is example 3b. I'm given my rational, is 40x to the fourth plus a 4x squared minus 1 over 10x to the fourth plus 8x squared plus 1. So right now, we are going to take my limit and we're going to work that through. The limit as I approach from the left and the limit as I approach from the right. Oh, well, positive and negative infinity is what I'm talking about. The limit as x approaches infinity here of 40x to the fourth plus this 4x squared minus 1, 10x to the fourth plus 8x squared plus 1. What's my highest exponent? This 4, and I've got it on the top and the bottom. That's fine. So I'm going to multiply by 1 over x to the fourth. And when we simplify that, I'm just going to straight up simplify this so we don't have to write a ton of steps. This x to the fourth and this x to the fourth are going to break this down to just be 40. This x squared divided by x to the fourth gives me an x squared in the denominator. And I don't have anything as an exponent there, so nothing can cancel out. So I just have 1 over x to the fourth. Then I have 10 plus 8 over x squared plus 1 over x to the fourth. Do you see what just happened there? Just simplifying that. It's like this is over x to the fourth for all of this. And you just simplify those down. That goes to 0. That goes to 0. All of those go to 0. And I'm left with 40 over 10, which is 4. You see that? So the same thing is applying here. I have x to the fourth. Because this is this odd exponent, this even exponent, it doesn't matter if I'm going to positive or negative infinity, the same thing is happening there. So even if I were to take this limit as x approaches negative infinity of the 40x to the fourth plus 4x squared minus 1 over 10x to the fourth plus 8x squared plus 1. Then whenever I break this down, because it's x to the fourth, because this is even, as I take negative infinity to an even exponent, that's still going to be that positive infinity, and we work this the same. The limit as x approaches negative infinity of 40 plus 4 over x squared minus 1 over x to the fourth, 10 plus 8 over x squared plus 1 over x to the fourth. Whether I go from to the right, from the negative infinity or the positive infinity, we're going to make it to the same value because the highest exponent is even. Because that highest exponent is even, then we're working this out and we're pulling that off. All right?